Morning, everyone. Morning. Can you hear me?
Morning, doctor. Can hear.
Morning,
Morning.
Doctor.
Good morning. Welcome to MDR 3013, Hematology and Immunology. Hope everyone had a good Raya. They're calling it Raya ad hoc, yeah? But I hope it was good and you managed to spend time with family and friends. I'm Prof. Shamili and I am the coordinator for this course. So I'll be delivering the introductory lecture. And I want to spend a little bit of time talking to you about the course first, yeah? Shall we do that before we jump into actual immunity? So the course is called Hematology and Immunology. So it consists of two subjects, yeah, which is, as the name of the course suggests, hematology and immunology. So you have 4 hematology lecturers this semester and 4 immunology lecturers. And then there'll be one lecture within the immunology subject delivered by a microbiologist. Yeah? So yeah, two subjects within this module, and you will, as usual, have your assessment. And for this course, MDR 3013, your assessment will be somewhere in the middle, so you can take a look at your timetable. And the reason why we place the assessment somewhere in the middle of the course is because this course is a nightmare. Just kidding. This course, we believe that it's quite technical. This course, it's quite complex, and that's not necessarily a bad thing. And so, rather than keep the assessment right at the end, we thought that it's good for you to assess your understanding of the two subjects in the middle. And the whole idea of the medical course compared to other courses is that there's that element of remedial, right? So you do your assessment in the middle, you are assessed on a certain number of topics, obviously not the entire course. And when you get your results, you see, whether you're in good standing or not. And if you're not performing very well, then you still have, another half. Kindly mute your microphones, yeah? Who is- Let me see who that is. No, Amrina? No, Amrina?
Yes.
Can you kindly mute your microphone?
Tahu.
Nanti bila I nak tanya soalan, I'll call you. What was I saying? Yeah, so it's all about remedial. So your assessment is right in the middle. And if you have any questions, you can forward it to your class rep, Farisha. I've been in touch with Farisha. Hi, Farisha. And she will forward me any questions or anything that you need to know about the course, and then we can take it from there. And this year, for this subject, we will be using Google Classroom as a platform. Have you all used Google Classroom before?
Yes, Doctor.
Okay, good. So you're familiar with it. And the reason is because Putra Plus is having some problems, yeah? So we will post our lectures, our assignments, our handouts all on Google Classroom. Okay, are those the main things? We're obviously online, but we won't have to wait too long before we face to face because we have a practical tomorrow, all right? And practicals are definitely face to face. Okay, I think those are a few of the housekeeping announcements I wanted to make. And now let me do my job in the sense of being an immunology lecturer, and let's talk about immunology. Is that okay?
Okay, Doctor.
All right.
Good, doctor.
Now, yeah, great. I want to talk about immunology more as a subject first, and then we'll talk about actual immunity, because you know generally what immunity is, you know what you're going to learn within the immunology course. But I want to talk about it in terms of a subject and how do you approach it as a student of the subject. So immunology, I don't know if you've heard from your seniors, they might find it okay. Some people find it a little bit complex, and let me tell you why. Now, the first thing that we have to understand about immunology as a subject is there are so many words in immunology that are very specific in terms of what it means within the immunology subject. So you will hear about terms like T cell activation, and activation in this context means something very specific. And you'll hear a lot of new terminologies. I mean, every subject, I suppose, you will learn new terminologies, but there's a lot of the immunology language itself is something that you need time to get used to. All right. So if you find that at the beginning belum faham the subject tapi macam dah confused with the terminology, let me tell you that that's normal, and let me give you some suggestions. All right. I think you should spend some time at the beginning of the immunology course getting to know some terminologies, and you will pick up the terminologies in our lectures. So pay attention to those words and maybe create your own glossary. You know what a glossary is, right? At the end of a textbook, you have, the meaning of all these different words. Why don't you create your own? And when you create your own, the benefit of that is words that you already know, you don't have to put in your glossary. You just put down terminologies that you forget or that you're confused about, and you always can go back to it as a guide. So again, you have to get used to the language of immunology and even hematology, perhaps. So that's my first suggestion, create a glossary. And then the other thing about the language in immunology is you can have many, many different groupings when you talk about, for example, immune cells. And, groupings don't exist in real life, right? Our body doesn't know that there are cells within different groups. We create groups because we want to try and understand systems. So let me give you an example. You would have heard of the terminology leukocytes before. And then you've heard also of lymphocytes, perhaps. And then you're like, no, hold on, what's leukocytes again? What's lymphocytes? Is there overlap? What are the cells that come under the terminology leukocytes? What are the cells that are considered lymphocytes? So again, this will take time to get used to it. And here is where I suggest you pay attention in immunology. And in our lectures, we are teaching you about immunity. You, in your free time, should find ways to understand different terminologies and try not to get confused because there is overlap between certain terminologies. Okay, so that's the first thing I want to talk about, the immunology language. So again, we haven't even talked about immunity, or I haven't started teaching you, yeah? I'm just telling you what to expect in the course. And speaking about what to expect in the course, let's take a look at the list of lectures that fall under immunology. All right. So here you have all the immunology lectures listed out, and I want to show you that we have arranged it in a particular way. Okay, so the first half of the immunology course is all about basic immunology. So you're going to learn about immune cells like neutrophils and macrophages and how they do what they do. You're going to learn about antibody and the structure and how it gives us immunity. You're going to understand how the immune system recognizes that there's a problem. So these are what we consider basic immunology topics. And once we have gone through the basic immunology topics, so I would say after HIM 28, yeah, integration of the immune responses, that's your basic immunology. And following that, you have what we call topics in applied immunology. So once you know about immune cells and how the immune system protects us and how it works, how it functions, then we'll start talking about vaccination. Then we'll start talking about allergy and autoimmune diseases. All right, so that's how the immunology course is split up. You've got basic immunology, then you've got applied immunology. And a lot of the things you learn in applied immunology will be about diseases that relate to the immune system, but also other aspects of applied immunology. For example, like immunization. That's not a disease, right? That's a protective approach. By the way, any questions at all you wanna ask, just interrupt me at any time. Yeah, so that's how the course is laid out. And for your first assessment, when it comes to immunology topics, this is what you will be tested on. Yeah, and I will share this information again with you if you need it, but it will be in the notes anyway that I post on Google Classroom. Okay, so from day one, you know what are the topics that will be asked in your assessment. And a lot of the topics are on basic immunology and then a little bit of applied immunology. So have a very strong basis, a very strong hold on your basic immunology, because I mean, I don't want to make promises, but I promise you that if you have a strong grasp on basic immunology, then applied immunology becomes easy, because even if you don't remember a great amount of detail, because you know enough basic immunology, you can rationalize what you learn in applied immunology. So that's my other tip. Now, the last tip, sorry, no tips on exam questions ever from me, but I have a lot of tips about how to study. All right, so the last tip on studying immunology is understand the concept before we confuse ourselves with the details. Okay, because any subject can get quite detailed, right? And I think naturally we are very good at reading notes, and then we sort of zoom in on the details, and then when you zoom out, you're like, okay, I'm learning about antigen presentation and MHC class 1, but then this relates to what exactly? So always, especially in immunology, understand the concept first, the big concept first, and then go into the details. All right, any questions about immunology as a subject? Okay, if not, let's get to the actual lecture. Okay, so I'm going to introduce you to the immune system this morning, and what I'm going to do is we're going to discuss what immunity is, and that the immune system does not consist of just one organ. So it's not very easily identifiable, right? So, for example, the central nervous system and the peripheral nervous system, it's quite easy to understand, what we're talking about, because the CNS is made up of the brain and the spinal cord, and that's it. And then the PNS is the PNS. But you don't have, an organ or two organs involved in the immune system, and that's it. And what I mean by that is immunity is everywhere in your body, because immunity is made up of cells, it's made up of different molecules. Some tissues have a role to play in immunity, and then some organs. And you also have what we call barriers of immunity. So it's everywhere within your body, and that makes sense. Because the best analogy you can have in your mind when you're learning about immunology and immunity is war, right? And so if your body is a nation, is a country, and you can be attacked by enemy at any point, you would want some form of defense everywhere, within your country, some form. And that's what your immune system is designed to do. So you have immune cells, immune molecules, and then you have some organs that have a very important role to play in immunity, but also almost all your other organs, even the heart, even very much so the liver, muscles, they all have immune cells, because it's always about what if this tissue has an infection. or has an injury? Do we have cells and molecules within that area to be able to begin the defense against attack? All right. But nonetheless, you have a group of immune cells that are very important to immunity, and we're going to talk about them in this hour, and we're going to talk about where they are in your body. So this hour is very much about visualization. Before we get into details of how things work, let's try and imagine where everything is within our immune system and what they do. I'm also going to introduce you to the concept of innate and adaptive immunity. And here's another thing, right? Concepts are always going to be boring unless you or I make it relevant. All right. So when we discuss innate and adaptive immunity, we can think of ways how, okay, innate means this and adaptive means this, and all of this is boring, but how is it relevant? Why do we need to talk about it? So the lecturers will always try their best to make it relevant, but we don't have 24 hours with you for the next 3 weeks, right? So that's another tip for any studying that you do, regardless of which subject. I suspect if you make it relevant to you, even if it's the smallest relevance, it automatically becomes something that you are interested in. We're going to talk about active and passive immunity, and then I'm going to quickly list for you the diseases of the immune system. So it's very much an overview of immunity. What's immunity? Where are all our immune cells, our immune tissues, and our immune organs? Some terminologies that has to do with grouping of immune responses, because if we group immune responses, it's easier to talk about them. So active immunity, passive immunity, innate, adaptive. So that's more about terminology and grouping. I'll introduce you to that. And finally, diseases of the immune system. And immunology will come to you in layers. All right. So your first lecture, you will possibly be not necessarily confused, but wondering what else is there. That's your first lecture. Then your second lecture, you'll start hearing words that you heard from your first lecture. And then your third lecture, things start clicking into place. And then your fourth and your fifth. Immunology is very much like that. So the first few lectures on basic immunology are very much like jigsaw puzzle pieces. And then hopefully by the end of basic immunology topics, you have the puzzle complete. All right, so let's start by describing immunity. Why do you think immunity is essential to life? Anyone?
Yes, doctor.
Why?
Yes,
do you
doctor.
think it's essential to life? Because you want to make the immunology lecturer happy and think her job's important? No. What makes you think it's essential to life?
As protection, doctor.
But why is it essential, you think, to have that protection? Without an immune system that is fully functioning, if we don't have a fully functioning immune system, or if we don't have an immune system at all, do you think we can survive?
No, doctor.
Yeah, we will probably succumb to infection pretty quickly. So that's how important immunity is. Of course, the cardiovascular system is also, incredibly essential to life, right? We need a pumping heart, but your immunity as well, because without an immune system, we will succumb to infection. So in there, you immediately understand the role of the immune system. It is to protect us from infection. Correct or not? By the way, when I've just switched the way I'm presenting, can you see the full screen, or do you see like all the peripheral stuff?
Full screen, doctor.
Okay, thank you, Fong. Now, what did I just ask? Yes, so correct or not, that's what the immune system does for us. Now, when we give our lectures, we'll be sort of constantly checking in with you. So, feel free to unmute your microphone and say yes or no, or what are you talking about? Okay, because we can't see you, we can only hear you. So, we need to hear your feedback. Now, is that all the immune system protects us from? Infection? Does the immune system protect us from anything else? Can you think of any day-to-day circumstances that the immune system protects us from?
Cancer.
Very good. Was that Fong again?
Yes, doctor.
Okay, Fong. Why do you say cancer?
Kill precancerous cell.
Yeah, and I'm very interested. How did you all know about this function of the immune system?
We learn it in biochemistry lecture.
Yeah, great. So that's the idea of an integrated syllabus. So let's talk about cancer for a while. Now, when you heard that for the first time, oh my gosh, immune system also protects us from cancer. Did it make sense to you, or were you like, huh? I thought it was all about infection. Safia, are you here? Safia Muhammad Ayub? It's terrible, huh? We have a list of all your names and I can call it at any time randomly.
Yes,
And
doctor.
hi, Safia. So, are you surprised that the immune system also protects you from cancer? I mean, maybe you're not surprised now, but the first time you heard it, what did you think about that?
No, I'm not surprised
How come you were not surprised?
because when we learn about the function of the immune system, the way they do their job makes sense that they protect us from cancer.
Yeah, so it's really interesting that even though the immune system was designed primarily to protect us from infection, it's not just about protection from, bacteria, viruses, helminths, fungi, protozoa. It's not just that, is it? It's protection from cancer, very sophisticated answer, but it's also protection from, your own cells. If all of our cells have a life cycle and a lifespan, and cells within your body are constantly dying, right? It's normal. And dead cells are actually a form of stress to the body because they need to be cleared, all right? Because dead cells are not healthy living cells. They can cause damage. So on a daily basis, your immunity is working even if you are infection free, because dead cells need to be cleared away. And what about wounds? You could have a sterile injury, an injury that has no infection. For example, if a surgeon is performing surgery and he's in a sterile room and all of his tools are incredibly sterile, if he accidentally cuts himself, theoretically that could be a sterile injury, and still your immune system is called into action and it's like, hey, what's going on? There's a breach of entry and we have to do what we need to do. So immunity is absolutely about protection from infection, but it is also about protection from all sorts of other stresses: cellular stress, sterile injury, tumor cells, and it's also about an element of wound healing, right? After there is infection and after there's injury, you need to start the process of healing, and the immune system is also involved there. So there you go, your overview of what your immune system does for you. And it's a simple role, but it's a very important role, and therefore how the immune system does what it needs to do is incredibly sophisticated. And that's what you'll be learning throughout the first half of the course. All right. Now, everything you see on the screen will be available to you after the lecture. I will post it on Google Classroom. And I don't usually go through all my PowerPoint slides because I want you to pay attention, if possible, to what I'm saying. and the details you can read on your own, because my notes, you hopefully are quite complete, so you can read it on your own. So don't be alarmed when you see my notes and you're like, oh my god, she didn't cover this. I don't intend to cover everything in my lecture. I want to give you overviews and concepts, and certain details I'll share, but others that I think you can read on your own, I want you to read on your own. Okay, so yep, we just discussed what our immune system does for us. Now let's talk about what our immune system is. So when you think of immune system, what organs or cells or components do you think of? Let's see. Anyone want to try? Is Hafi Akmal here? Hafi? Bradley, are you here?
Ada, Doktor.
Hi, Hafi. Okay. Hafi, when you think of the immune system, what do you think about in terms of the components? What makes up the immune system?
White blood cell.
Yes. And white blood cells, now here's where we must get straight about the terminology, okay? White blood cells, are they one type of cell or different types of cells? Do you know, Hafi? Or you're not sure?
Macam pernah belajar.
Tak apa. That's my job, to make sure that you all know, and if you all don't know, I will clarify. So here's the other thing about immunology. Sorry, I'm going to constantly talk about immunology as a subject. If we know what you don't know, that is how you will learn the best. So in a weird way, I don't really need to know what you understand, but I need to know what you don't understand, or macam tak ingat, and then I think that will be more beneficial. Okay, so here's a great example, of take the time from now on to understand what all these words mean. So Hafi, you are absolutely right. One of the important components of our immune system are white blood cells, but let's understand what that means. So white blood cells are not one type of cell. Okay, everyone? I mean, some of you may know this and some of you may not. Doesn't matter. Hafi, they are made up, for example, of cells like neutrophils, eosinophils, macrophages, monocytes. Hafi macam pernah dengar, right? All of these cells.
Ya, Doktor. Saya macam yang satu hari tu.
Yes. So today your take-home message is white blood cells are not one type of cell. It's a name, a general name that we give to a group of cells in the blood and in the tissue that have functions in immunity. All right. So okay. White blood cells definitely make up part of our immune system. Right now, others, can the class start shouting out different names of white blood cells that you have heard before? So I mentioned some like neutrophils. Just randomly start telling me the name of different white blood cells.
Monocyte.
Eosinophils.
Good. Eosinophils.
Basophil.
Very good. Some more.
Neutrophils.
Neutrophils. Good. Any more?
Lymphocytes?
What was that?
Lymphocytes.
Lymphocytes, yes. Who was that, by the way? Nisa, is it?
Yes, doctor.
Okay, very good. Lymphocytes, but again, I see some chats coming through. I'll check it after this. But another pesanan, lymphocytes also is a general word that we give to a few specific cells. So Nisa, you are 100% correct, but I just want to let everyone know that lymphocytes also is a general word. Like WBC, white blood cells. It doesn't mean one type of cell, it means several different types. Lymphocytes, if you want to list what are the different types of lymphocytes, they would be things like B lymphocytes, or we call them B cells, and T cells. Yeah, Nisa?
Alright, doctor.
Yeah, good. But it's correct. It's 100% correct as an answer, but I want to make sure that you all know, yeah, what it means. Natural killer cells also falls under lymphocytes. And again, any of this, if it starts getting like, oh my God, this is like, immunology will come to you in layers. So remind yourself at each lecture what all these things mean, and everything will be fine. Nothing will be fine from the first lecture, but by the 8th lecture, you will get the full picture. All right. So let's see, neutrophils, monocytes, eosinophils, basophils, lymphocytes, specifically T cells, B cells, natural killer cells, dendritic cells, mast cells. Mast cells you definitely would have heard of before, right? Yeah, good. Nazuha, I see all of your answers. Nasuha. Yeah, all of these are cells that have a very important role to play in your immunity. And all of these cells that we have just listed are what we call white blood cells. So we are coming back full circle to Hafi's first answer. All right. All of the neutrophil is a specific cell, eosinophil, basophil, T cell, B cell. These are actual specific cells, but collectively, all of them are known as white blood cells. There's another word that we give for white blood cells. Do you know what it is? Anybody? Have you heard?
Leukocytes.
Yes, from leukocytes. Okay. So again, pay attention, yeah? Get used to the language of immunology, because I know that by the time you finish, you will understand immunology very well. But the sad thing is, in an exam question, if we asked you a question about some disease and then we say which leukocyte is involved, if you forgot what leukocyte means, but you know what WBC means, it's such a shame, because actually you know the answer. If I was there to tell you leukocytes means white blood cells, same thing, then you would get to the answer. So do yourself a favor and take the time to know that, oh my God, some of these terms are general and what do they mean specifically, and sometimes one thing has two names. So take the time to do that, okay? Because we want you to have the best chance possible during your exams. All right, enough about immune cells. Do you think there's anything else involved in your immune system and in your immunity? What else comes to mind? I don't want you to think about, oh, what have I learned before? But if you just think as a normal, regular person, not as a medical student, even just as a general science student, if you think about immunity, does anything else come up in your mind other than all the cells we talked about?
Antibodies and plasma cells.
Yeah, I would definitely think about antibody also. I think even the layman, especially post-pandemic, will know about antibodies and how they have a role in immunity. And yes, plasma cells are a type of immune cell also. What else? I'm trying to show you that you've been doing my job for me. I've spent half an hour not really talking about immunology, but showing you what you already know, all right, and clarifying certain things for you. What else? Where do all your white blood cells come from? Which organ is responsible for producing white blood cells? Do you know?
Bone marrow.
Yeah. Someone said bone marrow. Any other question? Any other questions? Any other answers?
The lymph node, doctor.
Okay, great. Who was that? Scary, yeah? When I asked who was that, like I'm gonna shoot down. No. Who was that?
Nisha, doctor.
Okay, Nisha, is it?
Yes.
Yeah. So the organ that synthesizes all of your blood cells, not just your WBC, but your RBC and your platelets. So here we have a bit of hematology. That's why these two subjects come together sometimes. The organ that's responsible for synthesizing all your immune cells is the bone marrow. Okay, so I'll come back to you, Nisha, but it's the bone marrow. And that's why the bone marrow automatically becomes an organ that you should think about when you think about your immune system. All right. The bone marrow is the site of production for all your immune cells. Bone marrow. Now, Nisha mentioned lymph nodes. Now, Nisha, you are absolutely right. Lymph nodes are incredibly important for our immune system. All right, Nisha? So you take in that information first. You're right, lymph nodes are definitely part of your immune system. But lymph nodes are not the organs that produce your immune cells. Okay, Nisha?
Okay, doctor.
Okay, so I'll minus 10 points now itself. Just kidding. But here's what I want from all of you all. Give me the right answers, sometimes give me the wrong answers, and then we can correct ourselves. Okay, so Nisha, remember, lymph nodes are very much part of your immune system, but their function is not to produce immune cells. We'll come to their function another time. Okay, so class, collectively, although I don't know how you're going to answer collectively, just everyone switch on that microphone perhaps. Which organ in your immune system is responsible for synthesizing your immune cells?
Bone marrow.
Bone marrow.
Yeah, it's bone marrow. Okay, so let's recalibrate. What are we talking about? We have spoken about the function of your immune system, right? It's there to protect us from infection. It's also there to protect us from cancers and any sort of stress that affects your body. And what makes up the immune system? Well, first of all, a whole lot of different cells are part of your immune system. And collectively, we call them white blood cells or leukocytes. And if we want to list all of our leukocytes, it's quite a long list, right? And you will learn more about it as you go on. And then we also remember that antibodies are also really important in immunity. And antibodies are not cells, yeah? Antibodies are molecules. So you begin to appreciate that the immune system is made up of cells, but it's also made up of molecules and mediators. And it's also made up of organs and tissues that are very important for immunity. For example, bone marrow, where all your immune cells are produced. Lymph nodes are also very important. Thymus, you will learn later, is important. Spleen, liver. And in terms of tissues, if you have a sore, I shouldn't have given that away. If you have a flu, how do I put this? Let me just say it as it is. If you have a sore throat, what exactly is sore? What has swollen in your throat?
Inflammation.
Yeah, but what's the tissue that has become swollen? If you have a sore throat.
The tonsil.
Yes, tonsils are part of your immune system as well. But it's a tissue. You don't call your tonsils an organ, poor thing. Huh? It's downgraded to a tissue. So you also have tissues in your body that are very important in immunity. Your tonsils, your appendix, something known as mucosa-associated lymphoid tissue, which you will learn about. So I'm always assuring you, even if some words sound new, you will learn about it, right, as you carry on. So there you go. Immune system made up of cells, mediators, tissues, and organs. All right, and that's summarized in this slide. I haven't listed everything, but it's there to show you, oh yeah, these are cells, these are mediators, these are the tissues, these are the organs. All right. Any questions so far?
No questions so far, Doctor.
Let's take a breather as I decide what I want to tell you next. You still can see my screen, right? Yeah, you can. Okay, now in my lecture notes, sometimes you'll see this symbol, which I thought was quite cute. And that symbol is to show you that this is some self-learning or some homework that you can do on your own time. All right. So here's, I think, a good exercise for you when you're bored and when you have some free time. You start classifying your immune cells. Yeah. So these are the kind of slides that I won't go through in the lecture, but every time you see that symbol, you know lah. Yeah, let's talk about barriers. Hold on, yeah. Right, so we jumped into cells, mediators, tissues, organs, but I want us to take a step back and first realize that before our immune cells come into action, there are certain barriers that pathogen have to cross before our immune system is activated. And so those barriers are also defense mechanisms, right? So again, if we think about war and a country has borders, right? And those borders either have fences or walls to be the first line of defense, if you like, against the enemy. All right. So if that's what barriers means in immunology, can you think of any barriers that you have? Other than mental block barriers, just kidding.
Skin.
Yes. All right. Now here's the thing also, right, about the learning of medicine. Skin is there for many different functions, right? It's there to provide thermal protection. It's there to do this. It's there to regulate temperature and so on. But understand that the skin also serves as a barrier to infection. So we will talk about the skin even in immunology, but you know, the idea is not to always think about an organ in isolation. So I have to talk about the skin in terms of immunology, but you don't forget, you know, that all of these organs have multiple functions. The spleen, for example, yes, it's important in immunity, but it also has a very important role as a blood reservoir. Okay. So yes, your skin is a great example of a barrier to infection, and therefore it is part of your immune system. And it's like literally like a physical barrier, right? And the best way to appreciate the relevance of skin in your immunity is to think about burn victims, right? In patients that have severe widespread burns, what do you think is usually the main cause of mortality? If you, I mean, again, this knowledge doesn't have to come from class. It can come from movies. It can come from real life. It doesn't really matter. It's just about thinking. A lot of burn victims actually succumb to dehydration, isn't it, guys? Did you consider that?
Yes, doctor.
Yeah. But when it's really severe and widespread, there's also something else that tends to be the main cause of death in burn victims, and that is
Hypothermia.
I'm thinking more about infection.
Sepsis.
All right. Yes, and so severely burnt victims are at a great risk of infection, and I've got some statistics for you. Infection can sometimes be responsible for up to 51% of deaths in burn victims, and in some papers it's even higher. Something came in the chat. Infection, exactly. Guys, if you, I mean, really, I really don't mind if you switch on your microphone and menyampuk. That's much easier and much nicer because I get to hear your voice. But yes, infection. So that tells you, that gives you an idea of how important the skin is as a barrier to infection. So these are what we mean by barriers. And I have a slide here that you can look at in your own time. And we begin to understand, or you probably already know, but we begin to appreciate that, oh yeah, mucus is there for a reason, and my respiratory tract has cilia, and it's there for a reason that's related to immunity. And the gastric juices that I have are acidic, and it's acidic because it helps with digestion, yes, but that acidity also helps us in terms of immunity. So these are what we mean by barriers to infection, and barriers that you and I have to sort of be the first line of defense when it comes to our immunity. All right, so go through this slide in your own time. But we do have, you can see already, even if you're like, I don't want to read these words on the slide right now, but you can see that the diagram on your right, there's not just one or two labels, right? There's at least 10. So even if you're in the mood where I don't really want to read this right now, which I completely understand, at least you can take away that, hey, we don't just have one or two barriers now. When I come to think about it, when I look at this slide, we have quite a lot. So again, at every point you can be studying, even if it's very superficial, but it's still studying. All right, let's move on. So that was all about barriers of your immune system. All right, before we jump into what do neutrophils do, what do macrophages do, what does the spleen do, remember that first, all of the pathogens that we encounter have to go through a barrier. And oftentimes the barrier is enough to prevent infection. But if the barrier isn't enough, and the pathogen can pass through the barrier through whatever mechanisms, there's then a breach of entry, and that's when your white blood cells or your leukocytes come into action. Okay, so we're getting into the meat of the battle. All right, so you have barriers. If the barriers are breached, so it's all very much analogous to war, then you start activating your immune cells. All right, guys, everything okay so far with the lecture?
Okay, doctor.
Okay, any
Yes, doctor.
questions? Okay. The sillier the question, the happier I will be, honestly. So there's no silly question. Right, let's move on. Burns, Yep. So,
Doctor, is the microbiota gut at the gut considered a barrier? Because in the picture previously, it was mentioned together with other barriers.
yeah, so this is something nice to know, but that's the thing, right? Microbiota, if you were to learn about microbiota in a different subject, I think the focus could be on the fact that, it helps with digestion and so on. But it also, everything can have multiple roles, right? And in immunity, we do consider the microbiota as a good feature for our immune system, because the population of bacteria that make up friendly bacteria, in a way, the side effect that comes from that is that population of healthy bacteria prevents populations of pathogenic bacteria from growing. So it's sort of like a secondary effect. And if we want to list every single component in our body that's involved in the immune system, actually that list could be endless, and that shouldn't frighten us, and that shouldn't worry us, because that's us, right? That's the body, and the body's amazing, and the immune system's amazing. But if you're wondering, okay at which point do I start to understand what is essential for me to know as a student, and what is important when it comes to exams, because we can't run away from exams, right? Well, that you will know as we go through the lecture. But yes, Fong, sorry, I took your question as a chance to talk about how there are many things that can be part of the immune system, and which might be like worrying to you as a class, right? So, will microbiota be the right answer when I list, barriers to infection? Well, yes, it's definitely a correct answer, but there are so many other barriers also, the skin and so on. But to answer your question directly, Fong, we can definitely we do consider the microbiota as part of immune system, because it has the secondary effect of preventing infection in the gut. Is that okay, Fong?
Yes, thank you, doctor.
Yeah, and actually, when you do get my notes, and then you like, Alama, I couldn't ask her about Celia because she said she's not covering it in her lecture. But that's the beauty of Google Classroom. The more you disturb me in Google Classroom, the better. So during these 3 weeks, my primary focus is the teaching of MDR 3013. Research and everything can wait. So don't hesitate to ask me anything because you are supposed to learn continuously, not just during the lectures. Okay, guys? But yeah, thanks, Fong, for that question. So let's get back to leukocytes. And why are we talking about your immune cells? Because we just talked about barriers. And once barriers are breached, that's when your immune cells start coming into action. All right? So you remember what immune cells are? You listed them for me. Neutrophils, monocytes, macrophages, T cells, B cells. So let's take a step back again. And let's first talk about where are all these cells? Anyone wants to contribute? Because sometimes I get bored of listening to my own voice. Where are your immune cells? And there's not just one answer, there's many answers. Arif Najmi, are you here?
Yes, doctor.
Okay. Nice name, Arif. Yeah. Where do you think your immune cells are? They are in many places, but what do you think?
Thymus.
Yeah, they are in your thymus, but they are in your thymus. Let me tell you, everyone, yeah, you will learn a lot about what the thymus is for in practical 1 that's coming tomorrow. And Arif, yeah, you have immune cells in your thymus, but let me tell all of you as a class, in the thymus, your immune cells are there not to do their job. The thymus is there because it's a school for your immune cells. You will learn later that your immune cells, especially your lymphocytes, your T and B cells, they actually need to go to school within your body because they need to learn a few important things. And that's what your thymus is there for. So your lymphocytes are in your thymus, yes, but they are there not doing their job. They are there to learn. Does that make sense, Arif, for now?
Yes, doctor.
Good, okay. But yes, there are lots of lymphocytes, specifically T cells. There are lots of T cells in the thymus, but it's there to learn about how to protect your body, but it's not there to protect your body. So Arif, that was a great answer, because let me make my question a bit more specific. Once your immune cells are ready, right, to do their job, where do you think they are? Do you think once your immune cells are ready to protect, they are all in your bone marrow? Because that's where they came from, right? But do you think they're there?
No, doctor.
Okay, good. So you see, you are beginning to visualize it yourself. Bone marrow is where all our immune cells come from, and they go to school in the thymus. Some of them go to school in the bone marrow. You'll learn more later. But you know that they don't stay in the bone marrow forever. Do you think they go almost everywhere, your immune cells, or do you think they go to just 1 or 2 organs?
They go anywhere.
They go anywhere, and that's a good idea, right? Because immune cells are your soldiers. Do you want your soldiers only in Wilayah Persekutuan, or you want them everywhere, if possible? You want them everywhere. So okay, let me summarize for you where your immune cells are. A lot of your immune cells are in blood, right? It's circulating in blood, and that's good. Let it circulate. Let your soldiers move around looking for danger signs. But a lot of your immune cells are also in tissue. So the skin is full of immune cells like macrophages. Your heart has macrophages. Your gut has immune cells. Your brain has immune cells. So we're beginning to visualize, yeah? A lot of immune cells are constantly circulating in blood, but also most of your tissues also have their own immune cells. And then remember the word lymphocytes. Can anyone tell me what cells make up lymphocytes? Abhirami, are you here? Abhirami, are you here?
Yes, Dr. Andrew.
Okay, good. So you don't have to look up the answer, because if you get it wrong, then I think you'll get a trigger. Oh yeah, what I thought was wrong and now I know it's right. So I use the word lymphocytes. Lymphocytes is a general word. Do you know what cells are considered to be lymphocytes?
The B cells and the T cells.
Very good. Lymphocytes are B cells and T cells. I put it in the chat, yeah? Lymphocytes are also natural killer cells, but for now, let's just think about B and T cells, okay, guys? Now, I want to talk about your lymphocytes, your B and T cells, because your lymphocytes specifically, they're not always circulating in blood. And yes, you have some lymphocytes in your skin and in your gut and so on. But your B and T cells, your lymphocytes, actually love to home. The word is home. They love to home to particular organs within your immune system. And those organs are your lymph nodes. Yeah, pay close attention. Your lymph nodes and your spleen. So you will understand eventually that actually B and T cells are very, very powerful cells in your immune system, which is why sometimes we just talk about them, you know, in a very specific way, because they're very powerful. And your B and T cells, they like to home to your lymph nodes and your spleen. Whereas your neutrophils, for example, like circulating in blood. Do B and T cells also circulate in blood? Yes, they do. So they like to live in your lymph nodes and spleen, but they also like to take walks, okay? So yes, so I don't want you to be rigid and think, oh my God, that's in the spleen and they are never in the blood. No, that's not how your body works anyway, right? So you need to just remember that we're talking about the human body and it's very sophisticated, right? So nothing stays forever. So your B and T cells, do imagine that you have millions of B and T cells in your lymph nodes and your spleen right now. Millions, more than millions. It's actually 100 billion, I think. And that's where they like to live, but they also circulate in blood every now and then they go back to their homes. Okay, so I need a bit of feedback from you. Are you adding on to your visualization of the immune system? How's it going? Okay, I have a question from Mohammed. Can't see the full name. He wants to know if dendritic cells are classified under lymphocytes or leukocytes. So this is exactly the type of things that I want all of y'all to ask yourself. So Muhammad, I'll give you the answer right now, but in the future you'll have other questions which are good. You'll be like, natural killer cells, they fall under lymphocyte or leukocyte. And B and T cells, they are adaptive immune cells, you will learn later. But NK cells, are they adaptive or innate? Oh, they are not adaptive, but then they are also part of lympho. So it gets a bit confusing, but not really. You just have to be clear. Quick answer for Mohammed. Dendritic cells are not lymphocytes, but of course they are leukocytes. Let me ask a question to the whole class. Are all leukocytes lymphocytes?
No.
No.
Yeah, and are all lymphocytes leukocytes?
Yes.
Yes.
You got it. Okay, you got it. All right. Now a quick check-in. Your session after this is a self-study session, right? Yes or no?
Yes, doctor.
Oh yeah, so you don't have a class. So can I take an extra 10 minutes or so?
Yes, doctor.
Yes,
I'm
doctor.
taking, yeah, thank you. I'm taking extra 10 minutes because I spent some time at the beginning introducing the course, yeah. But in the future, all my lectures will remain 1 hour. But any questions you have, I will stay on after that, yeah. But it's not my aim to go beyond 1 hour for my actual lecture. All right, let's move on, okay, guys? And you can read certain things in my notes to make, the knowledge of immunology a bit more relevant. For example, in the future, as doctors and medical officers, you will be very familiar with full blood counts. And you probably already know what full blood counts are. And it's a great way to know within a patient what are the markers that are associated not just with blood but also your immune system. All right. And the reason why, by the way, quickly, have you all heard of full blood count before?
Yes, doctor.
Yeah.
Yes.
And you know that full blood count, you have your neutrophil count, your eosinophil count, your basophil count, and so on, right?
Yes, doctor.
So, instead of it being like boring, oh my God, full blood count has neutrophils, actually there's a relevance there. You now know that the immune system and the immune cells, they like circulating in blood. And they are circulating in blood because they're looking to see if there's any problems. And what we do as the medical fraternity, not that I'm a medical doctor, but as the medical fraternity, because immune cells are circulating in blood and that's what they should be doing, we can manipulate that and use that as a tool to assess a patient's immune status, for example. Okay, so even something as dry as full blood count, neutrophil count, this is the reference values, blah blah blah, but that also helps us realize, like, yeah, that's why a full blood count can be useful, because anyway immune cells are circulating in blood. And if I take a sample of blood from a patient and I see, oh my God, there's a lot of neutrophils circulating in this patient's blood compared to normal, that can indicate infection. All right. All right, so we've been speaking about organs already, right? Bone marrow, thymus, lymph nodes, spleen. So you will begin to realize that in immunology, we split your immune organs into two categories. We call them primary lymphoid organs and secondary lymphoid organs. So lymphoid organs, the lymphatic system, and lymph are actually very important components in immunity. And I'm going to summarize for you now what primary and secondary lymphoid organs are. But the whole idea of your practical tomorrow on organization of the immune system is to learn much more about your lymphoid organs. Okay, so you'll understand more tomorrow. But in a nutshell, your primary lymphoid organs, which are on this side of the diagram, are basically your bone marrow and your thymus. And primary lymphoid organs is a name that we have given to these two organs because we've realized that, hey, when it comes to the development of an immune cell, so an immune cell needs to be born and then it needs to learn a few things and become equipped, if you like. Now, for an immune cell to be born and become equipped and mature, there are two important organs involved, the thymus and the bone marrow. So those two organs, we automatically now call them primary lymphoid organs. So you can see on the slide, the actual definition is there. Primary lymphoid organs are where your lymphocytes mature. So that's where they're learning and growing. They're not doing their job yet. Okay. Now, once an immune cell is mature, so it's ready to meet enemy, it doesn't stay in the thymus. All right. So I forgot the student who talked about thymus earlier. So your functioning immune cells, once they are ready to do their job, they don't hang around in the thymus. They don't really hang around in the bone marrow. They enter the blood circulatory system and your lymphocytes end up in your secondary lymphoid organs, which is again a name that we give to the organs that we have where lymphocytes like to live. It's their home. And what I mean by that is the spleen, your lymph nodes, and then lots of other tissues like your tonsils, your adenoids, your mucosa associated lymphoid tissue, and so on. So tomorrow during the practical, we'll get to know your primary and secondary lymphoid organs much better. All right, but there you go. You have now gotten a snapshot view of lymphoid organs: primary, secondary. Primary is where your lymphocytes mature, but secondary is where they end up. Is that okay? Can or not, class? Can I move on?
Yes, doctor.
Now let's talk about your innate and adaptive immune responses. So that's the thing, guys. Yeah, when we teach any subject, we have to find ways to describe it to you, right? So we can think about the immune system in terms of lymphoid organs, primary and secondary. We can think of the immune system in terms of cells, molecules, tissues, organs. We can think about the immune system in terms of its function. But we also need to think about the immune system in the way it responds, because it's quite clever. All right. So you will learn about innate and adaptive immunity in your next few lectures. And you can read what's on the slide in your free time. But for now, let me just tell you that there are certain cells in your immune system that act really fast, and there are certain cells in your immune system that act slower. Slower doesn't mean bad, faster doesn't mean bad. We need them all. And the part of your immune system that's a little bit slow is also awesome, because that's the part of your immune system that has memory. And in immunology, what we mean by memory is the first time your immune system meets a pathogen is the first time. If it meets that pathogen a second, third, fourth time, your immune response will be better and faster. All right, so that's what we mean by immunological memory, and it's your adaptive immune system that has the memory. It's the innate that is fast. Which one's better? That's not the question to ask. You need them all. All right, so that's innate and adaptive immunity, and you have 2 lectures on this coming up tomorrow. Okay, but I'm just introducing you to the concept. Another way to think about immunity is active immunity and passive immunity. All right. Now, active immunity is this. For active immunity to work, you need an actual functioning immune system. So, for example, if I get infected with a virus, any immune response that I have is active. It's an active response because my immune system needs to be active and respond. Now that won't make sense, and that will be a bit dry, you're like whatever, until you contrast it with passive immunity. An example of passive immunity is the immunity that is passed from a mom to her fetus. All right. So you may know or you may not know that a mom's antibodies are transferred through the placenta to the fetus, and the fetus gets protection. That protection from the mom's antibodies is there passively. The fetus doesn't have to have its immune system to be part of that protection. That's what we mean by passive immunity. Another example of passive immunity is, for certain diseases, the therapy includes taking antibodies, that you get from another patient, and putting it into the patient that requires it. Those antibodies are already functioning. They're already going to protect. Your immune system, the patient's immune system, doesn't need to take part. That's what we mean by passive immunity. Now let me ask you a question to see if we've understood what's active immunity and passive immunity, okay? So everyone listen to the question, yeah? We're almost at the end of the lecture. You all know about immunization, right? You know what vaccines are, correct? Everyone's got their COVID vaccine. For vaccination to work, do you think that involves active immunity or passive immunity? And maybe you don't know, but what do you think?
Active.
Chester, are you here?
Yes, doctor.
What do you think? You roughly know how vaccinations work?
Yeah.
So do you think if I'm going to take any vaccination, for example, the COVID vaccine, once I get the vaccination, I get that protection because my immune system also has to get involved or no?
I
What do you
think the immune system is need to get involved.
Definitely, that's the principle of vaccination, which if the rest of the class you didn't realize, don't worry, there's a lecture on that later. But yes, Chester, you're right. It must include our immune system reacting to the vaccine. That's how we get the protection. So Chester, therefore, is vaccination considered active immunity or passive? Yeah, and let me show you the slide. What does active immunity mean and what does passive?
I think it's active.
Yes, I mean the answer's on the slide, I know, but it doesn't matter. You get it now, Chester, right? So the words active immunity and passive immunity is probably boring for you to remember, but if you put relevance to it, it will help, hopefully. All right, so you're right. Vaccination, if it works, it means that was active immunity because the patient's immune system had to get involved. Now, class, there's a question here for you all to prep for our SEL on 12th May. Yeah? So that's the question. And when you get the notes, the question will be there again for you to refer to. Okay, let's move on. And this is the last slide for the lecture. Okay. Towards the end of the immunology course, you're going to learn about diseases of the immune system, but I'm going to summarize for you and give you a very quick overview. You're going to learn about immunodeficiencies, hypersensitivities, autoimmune diseases, and transplant reactions. Okay? So, your immune system can cause you disease in different ways. The first scenario is if your immune system is deficient, right? If someone has something lacking or something not working properly, subpar, it's underperforming in your immune system, that can cause a whole group of diseases. And those diseases we call collectively immunodeficiencies. And that word, immunodeficiencies, deficiency. The word immunodeficiency helps you remember what we're talking about, right? Yes or no?
Yes.
Yes or no?
Yes, doctor.
Yeah, so the terminology also, even though it's dry, but you can make it useful for you if you sometimes realize that, the word represents what we're talking about. So there you go. That's one group of diseases related to your immune system. If there's something lacking or not performing well in your immune system, that leads to an immunodeficiency. And there's many different types of immunodeficiency that you will learn later. And then there's another problem about your immune system. If someone's immune system is reacting excessively, overreacting, or if it's reacting to something that actually it didn't need to react to, that is also going to cause a problem. And all of those disorders, we give them one name, which is hyper sensitivity. Okay, a good example of a hypersensitivity disorder is allergy. All of you know what allergies are, right? Now, if I'm allergic to prawns and my immune system is reacting to prawns, thinking that prawns is the enemy, but is prawns really the enemy? Is that a useful immune reaction? Zuleika? Oh, sorry. Siti Sabrina?
No, doctor.
That's useless, right? Why should my body think that, you know, prawns are the enemy? So allergies, which are hypersensitivities, you know, to various things like shellfish and peanuts, that's not really life-threatening, but the immune response to peanuts is life-threatening. So therefore it's a disorder, and it's a disorder of the immune system overreacting or reacting unnecessarily. So that's your second group. So you've got immunodeficiencies, and then you've got hypersensitivities. Now, the third group of disorders is when your immune system starts attacking your own cells and molecules, which sounds terrifying, and it is, but there's ways around it. And when that happens, that disorder is classified as an autoimmune disease. And the last condition you will learn about are transplant reactions, where transplantation itself is not a disease, it's actually a man-made creation to solve disease. But transplants can fail because of the patient's immune system, and they can react to the transplant. And so that is also considered a disorder of the immune system. So there you go. Diseases of the immune system. You've got your immunodeficiencies, you've got your hypersensitivities, your autoimmune diseases, and your transplant reactions, all of which you will learn during the course. Right, so let's circle back to your list of lectures. So there you go. That was the introduction of the immune system. And I will end today's lecture by summarizing the lecture. We now know what our immune system protects us from. We know our immune system is made up of cells, molecules, tissues, organs. We learn much more about these cells and organs, but for now, we know that the bone marrow produces immune cells, all immune cells. We know that some immune cells have to go to school, and they go to school in the bone marrow and the thymus. And those organs are known as primary lymphoid organs. And once your immune cells are schooled and ready for the world, they circulate in blood continuously. They also localize in different tissues. You have immune cells in your brain, liver, spleen, skin, muscle. But your lymphocytes in particular, they home to your secondary lymphoid organs, which are basically your lymph nodes and your spleen. So they're there waiting, and once in a while they take a walk. So that's where all your immune cells are. We didn't talk much about immune mediators, but you will know through future lectures that antibodies, cytokines, complement proteins, prostaglandin, histamine are all very important molecules also in immunity. Then we started thinking about immunity from different angles. We now know that there's something known as innate immunity and adaptive immunity, and it's all about which one is fast, which one's slower, which one has memory, which one doesn't. You will learn more tomorrow. And then we also thought of immunity from the perspective of active immunity and passive immunity. And then finally, we know that even though the immune system's awesome and we can't survive without immunity, but immune responses and our immune system itself can cause disease. So if your immune system is not functioning well, that's immunodeficiency. If it's functioning too well, that's hypersensitivity. If your immune system unfortunately starts recognizing your own antigens, your own cells and molecules, that's autoimmune disease. And finally, a very important part of transplant procedures is to make sure that the immune system doesn't reject the transplant or doesn't react to the transplant. So if there is rejection and reaction, again, that's your immune system behaving badly. It doesn't think it's behaving badly, but for us it's not a good idea if our transplant gets rejected. So there you go, an overview of the immune system. So that's HIM 22 done. And then, like I promised, you will learn immunology in layers. You're going to have lectures on innate immunity and adaptive immunity next. Everything you need to know about antibodies and cytokines and so on, you will learn in mediators of the immune system. In tomorrow's practical, we'll be able to visualize even more. What does a neutrophil look like? Where are they? What does the spleen look like? And so on. And then we're going to need to learn how does the immune system recognize the enemy. So that's antigen recognition. And then it all comes together. All of your knowledge of immunology comes together when we learn about inflammation, which you will learn in HIM 28. And then after that, it's all the good stuff. It's all applied immunology. Okay, class, I think that's it. Here's an example of a glossary that you can create for yourself. Please add on more, whether it's in a notepad or on your phone, it doesn't really matter, but that's what I mean by glossary. And for my lectures and most of the other immunologists, the main textbook is this one by Abbas. Right, thank you very much. I know that I've exceeded time, but my future lectures will be limited to 1 hour. You can leave the class if you want because we've gone over time, but any questions, I'm happy to stay on. Yeah. Any questions, even if you want to ask about attendance or notes, or you want to understand something I just told you, any questions you have, please ask me now. Yeah? Okay, no questions?
So far clear, Doctor.
All right, and let me just give you a final piece of, it's not advice. You will help me so much if you all are more responsive. You're pretty good for your first lecture. And when I say responsive, I'm not talking about giving me the right answers. If you can quickly say, yes, it's okay, no, it's useless, no, this is rubbish. If you can quickly tell me, that's how we can save time during the 1 hour. And questions. The more things you get wrong, the better you'll understand immunology. Okay, so those are my final words for this lecture. Thank you very much. I think within the next hour, you can definitely log on to Google Classroom and you'll see my notes there. All right, class, so welcome again. Enjoy the course, and we are all here to help you appreciate hematology and immunology. Thank you very much. See you all tomorrow for your practical at 2 o'clock. You can leave the class now. Thanks. Bye.
Thank you, Doctor.
Thank you.
Thank you, Doctor.
Doctor.
Thank you, Doctor.